Hello everyone and welcome to Simple Statistics. This is the first video on basic statistical concepts. Bear with me on the quality. This is just the first video, getting a hang of it, and we'll get there. We'll get to that pro level quality eventually. We'll call this video number 1. What is statistics? Well, statistics is the science of dealing with collection, analysis, and interpretation, and the presentation of data. So let's visualize that for you right now. And then we're gonna add a little arrow pointing this way. First, we're gonna collect data, analyze the data, interpret the data, and then present the findings. So next, what is the difference between population and sample? So picture this. Right here in this big circle, we got Joe, Lucy, Katie, all of these people. Consider it all of Canada. All of Canada right here. When the government of Canada is doing a census, reaching out to every single person is extremely expensive and sometimes just unfeasible. So what they do is they will take a small group right here, take this out, then we have a sample. Population, and over here we have a sample. So sample is just a small subset of the population, okay? A portion of the whole. To visualize that one more time to make it a little bit more clear. So population, and so on and so on and so on and so on. We have a bunch of data, bunch of data. Collecting every single person's information can be too tricky, too expensive, too time consuming. So what statisticians like to do is they will take a small random, keep in mind random, chosen at random sample. Oh, doesn't want to cooperate with me here. Here we will have, and then over here we will have our sample. So population is the whole data. Sample is a small subset of the whole, a small portion. A portion of the whole. Okay. So in statistics, there's a different language that statisticians use for a variety of things. So as we go, we're going to learn some new language, and you'll get the hang of it eventually. It's just some practice. But starting with this first example, going back to the population and sample, let's say we wanted to find the average of all of whatever we're trying to find in this population, but it's out of our reach to ask everyone in the population, 1, 2, 3, ask them all, what is the number that we're looking for, and then based on that number, we get the average for the population. This can be too tricky, too expensive in the large scale. So what we do, we go back to our trusty sample, or rather we have, instead of 1, 2, 3 to infinity, we go to our sample. Let's do a different color here. We go to our sample and we ask 1, 2, 3 people, what's the number? We ask them, what's the number? What's the number? And then we get the average, and we use this average to make an assumption of the population. So as an example here, in the sample, this is example based on what we did over here, but I'm going to visualize it in a circular fashion. So sample, we have X bar. X bar is equal to the sample average. We call it X bar, X bar. And this would be considered a statistic. Over here, population. we are looking for the population average, which we call mu. Pronounced as mu, mu. And mu is the population average. And we call this a parameter, because in population we call parameter as a descriptive measure of the population, and the statistic would be a descriptive measure for a sample. Let me make this make more sense. Mu is the average of the population, average of population, and x bar equals the average of the sample. This, since it's for a population, we call it a parameter. And we call x bar, since it's a part of a sample, and since x bar describes a component of a sample, we call it a statistic. So going back to our little box here. So over here, since we calculate x bar, the average of the sample that we took out from the population, we will use x bar to estimate mu, which is the population average, the average of the whole. And we will get our estimation of the population average, which is mu. Just repeating it multiple times, so kind of get a grab of it. And going into this loop again, if we have a population, we grab we select a random sample, and based on that random sample, we get our x bar, which is the sample average. Sample, once again, is a subset of the whole, something that's easier to work with. And once we have that, we calculate, once we have x bar, we can use it to estimate the population average. And this is a very high level explanation. There's a lot more to it where you get more specific and more, let's say, accurate, but at the basic level, this is what you should know for now. And we'll get more advanced as we go on. Just reviewing everything that we've gone over so far today. Statistics is a science dealing with the collection, analysis, interpretation, and presentation of numerical data. So step 1, we want to collect data. 2, analyze the data. 3, interpret data. And 4, present the findings. So, and then we also went over the difference between a population and a sample. Population, as in a big sum, the whole of the information, and the sample is a small subsection of the whole, which we can use to make assumptions based on the whole. I did some explanations, and we also went over parameters, which is a descriptive measure of a population. So that can be the average, standard deviation. It all matters on what we're looking at, but for right now, at the beginning of this course, we're going to be, in this case, we're looking at average. So mu is a parameter of the population, and x bar is a statistic, which is a descriptive measure, once again, before a sample, to be clear. Once again, population, sample. Sample is a small piece of the whole data. Well, thank you guys for watching the first video. Always feel free to leave a comment and I'll be happy to explain anything.